In March 1971, the balance of power in the Middle East was tilted by a ghost. 4 unidentified Soviet aircraft arrived in Egypt, operating from a secluded airbase. They bore no national markings, and they began to fly missions deep over the Israeli-occupied Sinai Peninsula, a region defended by the most battle-hardened and confident Air Force in the world. On October 10th, a pair of these intruders streaked 17 miles offshore, parallel to the coast. The Israeli Air Force scrambled its finest interceptors, the F-15 Phantom II, to meet the threat. The result was a humiliation. The Israeli pilots, loaded for combat, could do nothing. The Phantoms, straining at the edge of their performance envelope, were left wallowing in the dense air tens of thousands of feet below their targets. They were too slow, and they could not climb high enough. All the Phantom pilots could do was watch the contrails of the 2 aircraft painting a perfect, arrogant line across the sky at Mach 2.5 and extreme altitude, effectively invulnerable to any weapon in the Western arsenal. This event, more than any other, triggered the Foxbat panic. Western intelligence was terrified. A new Soviet aircraft, given the NATO reporting name Foxbat, was untouchable, and when they analyzed the spy satellite imagery, their blood ran cold. The aircraft had immense, powerful engines, clearly built for speed, but it also had enormous wings. In the calculus of Western aerospace design, large wings meant low wing loading, which meant one thing: high maneuverability. To withstand the searing heat of such high speeds, analysts assumed it must be built from exotic, lightweight titanium alloys, just like their own Blackbird. The conclusion was a nightmare. The Soviets had apparently built a super fighter, a single aircraft that combined the blistering speed of a reconnaissance plane with the agility of a dogfighter, rendering every fighter, every bomber, and every air defense strategy in the NATO playbook obsolete. The danger was not just the aircraft, but the implication. If the Soviets had secretly mastered the mass production of titanium airframes and engines this powerful, Western estimates of Soviet technology were catastrophically wrong. The MiG-25 was, for a time, the most dangerous aircraft in the world because it was a phantom of the West's own creation, a mirror reflecting their deepest technological fears. The entire panic, however, was founded on a spectacular misunderstanding. The aircraft over the Sinai were MiG-25 reconnaissance models, unarmed platforms on a data-gathering mission. And to understand the real machine, one must ignore the Sinai and look back more than a decade to a different threat, a different sky, and a completely different mission. The Mikoyan Gurevich MiG-25, the last aircraft designed by Mikhail Gurevich, was not born to fight phantoms. It was born from a specific and urgent Soviet fear of the late 1950s, the North American Valkyrie bomber. The Valkyrie was an American technological terror, a 6-engined strategic bomber designed to penetrate Soviet airspace at Mach 3, at an altitude of over 70,000 feet. This single aircraft threatened to render the entire, vast, and expensive Soviet air defense force completely obsolete. The requirement, therefore, was not for a nimble air superiority fighter. It was for a point defense interceptor. The mission profile was brutally simple, a philosophy of climb, catch, and bring down the American bomber. It was designed for a single, high-speed, rocket-like pass to engage its target. Every other metric that defined a Western fighter, agility, combat endurance, low-altitude performance, efficiency, was secondary. It had to be a pure interceptor, launched on a vector from ground control to destroy a non-maneuvering target in the stratosphere and return to base. Furthermore, it had to be mass-produced by the hundreds to guard the endless Soviet border, which dictated a design that was simple to build and maintain. This singular focus is the key to every flaw the West would later mock. It wasn't a failed dogfighter, it was a perfect anti-bomber missile with a man inside. The central engineering challenge was heat. Flying at Mach 2.8 or faster generates kinetic friction that heats an airframe's skin to over 300 degrees Celsius, a temperature that would turn the aluminum alloys used in typical jets into soft, pliable metal. The American solution for its Mach 3 Blackbird was an almost all-titanium airframe. Western intelligence, seeing the Foxbat's performance, assumed the Soviets had done the same, creating a light, strong titanium superfighter. The reality, when it was finally revealed, was a profound shock. The MiG-25 was not made of titanium. It was a 20,000-kilogram monster forged from 80% nickel-steel alloy. Only 9% of the airframe was titanium, used in small, critical, high-heat zones like the engine nacelles. This was not a technological leap, it was a pragmatic, brute-force solution. Titanium was eye-wateringly expensive and a nightmare to machine. More importantly, Soviet industry had not yet solved the problem of cracks forming in welded, thin-walled titanium structures. Steel, on the other hand, was heavy, but it was cheap, available, and crucially, it was weldable. This realistic compromise led to the Foxbat's infamous build quality, which was functional rather than refined. The airframe was assembled using a combination of spot welding, automatic machine welding, and crude, visible hand-arc welding. When Western engineers finally got their hands on one, they were appalled by the exposed rivet heads and rough finish, so different from their own polished, flush-riveted machines. But this crude construction meant it could be built and repaired easily by workers without specialized skills in the vast numbers the Air Defense Force demanded. This choice of steel is what exposes the single greatest intelligence failure of the Foxbat story, the large wing fallacy. NATO analysts saw the MiG-25's massive wings. Based on their own design philosophy, particularly John Boyd's energy maneuverability theory, a large wing area implied low wing loading, which was the key to a great dogfighter. They assumed this steel and titanium aircraft was light and agile. They were catastrophically wrong. The aircraft wasn't light, it was a 20,000-kilogram lead sled precisely because it was made of steel. The enormous wings were not for agility. They were a basic aerodynamic necessity to generate enough lift to get the heavy steel airframe off the ground at all. Its wing loading was, in fact, enormous, and the airframe was structurally limited to a modest 4.5 Gs, a load it could only pull at risk of damage, and one that made it less maneuverable than the Phantom it had so easily outrun over the Sinai. The West had panicked, believing a dump truck was a sports car, simply because it had a huge engine. And what an engine it was. To hurl this steel behemoth through the sky, the Mikoyan-Gurevich Bureau needed power, and they found it in the Tumansky R-15B-300, a colossal single-shaft afterburning turbojet. Two of these engines, each generating over 100 kilonewtons or 22,500 pounds of thrust on afterburner, were the heart of the Foxbat. But the origin of this engine reveals the aircraft's true design philosophy. The R-15 was not originally developed for a manned fighter. It was an evolution of the power plant for the Tupolev cruise missile, and more famously, the Yastreb reconnaissance drone. The drone's engine was, by definition, lower cost, short life, expendable. The R-15B-300 for the MiG-25 was modified for reusability, but it retained this disposable DNA. Its initial service life was a paltry 150 hours. This engine was the source of the Mach 3.2 plus speed that so terrified the West. But this speed was a myth, a piece of datasheet propaganda. The aircraft could reach Mach 3.2, but doing so was an act of mechanical suicide. The pilot's manual and later the plane's defector confirmed that the operational top speed was strictly limited to Mach 2.83. If a pilot exceeded this for more than a few minutes or pushed to Mach 3.2, the engines would literally destroy themselves. The turbine blades, pushed past their thermal limits, would overheat, warp, or even ignite, causing the engines to accelerate uncontrollably and requiring them to be scrapped upon landing. This was not a war emergency power setting, it was a buy a new engine setting. This engine philosophy also came with a crippling thirst. The R-15s were notoriously inefficient, pure gas guzzlers. Their specific fuel consumption at subsonic cruise was an abysmal 127 kilograms per hour per kilonewton, over 50% worse than the F-15's engines. This gave the MiG-25 an extremely short combat radius, reinforcing its role as a point defense interceptor that could only scramble, dash, and land. It was, in essence, a manned cruise missile, with the pilot serving as a biological guidance system for a ground-controlled, high-speed dash. This brute force philosophy extended to the avionics. When Western analysts finally disassembled the MiG-25, they were stunned to find that its massive Foxfire radar was not built with modern solid-state electronics, but with vacuum tubes. This was immediately derided as antiquated, junk, and engineering archaeology. But this was not technological backwardness. It was a brutally logical solution to a specific problem. The same kinetic heating that demanded a steel airframe turned the avionics bays into an oven. Solid-state electronics of the era would have fried. Vacuum tubes, while ancient, are more tolerant of temperature extremes and removed the need for complex and heavy cooling systems. A popular myth later arose that this was a brilliant piece of anti-nuclear design, as vacuum tubes are more resistant to an electromagnetic pulse. This is a compelling story, but it's more likely a factoid. Many engineers argue that the long filaments in vacuum tubes make excellent antennas for receiving electromagnetic pulses, and the real reason was simply thermal tolerance, combined with the fact that the Foxfire was a design from the mid-1950s, borrowed from another interceptor. Whatever the reason, this antiquated radar was no weakling. It was a 500-kilogram monster with an enormous 600 kilowatt power output. It was so powerful, in fact, that it was forbidden to switch it on with the plane on the ground, as its microwave beam could literally cook small animals and harm humans walking by. But this powerful sensor had a fatal flaw. It was designed to look up into the cold, empty stratosphere to find a high-altitude bomber. It had no look-down, shoot-down capability. It was effectively blind to targets below its own altitude, rendering it useless against the ground clutter. This was a catastrophic limitation. By the time the MiG-25 entered service, the Valkyrie was canceled, and NATO's strategic doctrine had shifted from high-altitude bombing to low-level penetration by bombers and cruise missiles, a threat the Foxbat was never ever designed to counter. The plane's entire reason for existing was already obsolete. Perhaps the most bizarre and revealing piece of engineering was the plane's lifeblood. To cool the avionics, de-ice the airframe, and operate the hydraulics in the extremes of the stratosphere, a Western design would have used a proprietary, synthetic, non-potable fluid. The Soviet solution was, essentially, vodka. Each MiG-25 was serviced with enormous quantities of high-proof spirits, up to 60 liters of pure medical alcohol, and 350 liters of a 60-degree water-alcohol mixture. One defector simply said it required 1/2 ton of alcohol per flight. This earned the aircraft its legendary nickname among Soviet airmen, the Flying Restaurant, or Massandra, after a popular Crimean wine. This created a logistical and morale problem that was almost a caricature of Soviet life. After each sortie, dozens of liters of unspent, high-grade alcohol were drained. This liquid became a universal currency on the airbase, and ground crews often drank some of the alcohol to stay warm. This led to incredibly dangerous situations where technicians, in a risky maneuver to privatize the fresh allotment, would refill the plane's vital cooling systems with spent or substandard mixture, a deceit that, if the systems failed at Mach 2.8, would be a guaranteed death sentence for the pilot. It is an engineering solution that is 100% technically logical and 100% humanly absurd. A perfect encapsulation of the MiG-25's design philosophy. The weapons system was the final confirmation of its single-minded purpose. The MiG-25P interceptor had no internal cannon. This fact alone, more than any other, proves it was never intended for a dogfight. Its sole armament consisted of 4 massive underwing pylons designed to carry the Biznavat R-40, known to NATO as the Acrid. These were not missiles so much as flying telephone poles. Each one was over 6 meters or 20 feet long and weighed a staggering 475 kilograms, over 1,000 pounds. Like the aircraft that carried them, the missiles themselves were built with titanium to withstand kinetic heating during their Mach 4.5 flight. They carried a warhead designed for one purpose: to annihilate a strategic bomber. The blast fragmentation warhead weighed between 35 and 70 kilograms, with some estimates as high as 100 kilograms. This was not a weapon to damage a fighter, it was a weapon to guarantee a kill on a bomber. The standard air defense tactic, entirely dependent on ground-controlled interception, was to carry 2 of each variant and fire them in pairs. 2 radar homing missiles to ride the massive beam of the Foxfire, and 2 infrared homing missiles to lock onto the massive heat signature of a bomber's engines. The entire intercept was a rocket-like pass. The ground controller would vector the MiG-25 into a firing position. The pilot would light up his radar, dump his 4 missiles from 80 kilometers away, and immediately turn for home. This was a battleship, not a fencer, and it was useless in a close-range turning fight. The defector even noted that in a tight turn, the massive missiles could be ripped from the wings. The monster and the myth remained a terrifying phantom until September 6, 1976. On that day, Soviet Air Defense Lieutenant Viktor Belenko, flying his MiG-25P from Chuguyevka Air Base, decided to defect. He performed the one maneuver the aircraft was not designed for. He dove below radar detection, hugging the waves at 100 feet to escape not the enemy's radar, but his own ground control network. Eating up fuel quickly, he pointed his aircraft at Japan. He landed in a dramatic, nearly disastrous fashion at the civilian airport in Hakodate, overshooting the runway, blowing his tires, and narrowly missing a passenger plane. He brandished his pistol and requested political asylum. For Western intelligence, this was the bonanza. They finally had the superfighter. U.S. and Japanese analysts descended on the aircraft and began to literally disassemble the myth. Belenko provided the cheat code, the aircraft's technical manual, which he was expressly forbidden from carrying. The discoveries were stunning. The airframe was crude, 80% steel, and covered in hand welds. The avionics were junk, full of engineering archaeology in the form of vacuum tubes. The engines were powerful, but would disintegrate at top speed. The plane was a lead sled that turned like a barge. It was not a superfighter. The myth was broken. The plane was eventually returned to the Soviets in 30 crates, with some parts missing. In a final perfect act of dry, bureaucratic humor, the Japanese government sent the Soviet Union a bill for $40,000 to cover damage to the airfield and shipping fees. But if the myth was dead, was the plane junk? No. The defection simply revealed that the MiG-25 was a flawed masterpiece. When used exactly as it was intended, it was still one of the most dangerous aircraft in the sky. Its most effective role, ironically, was the one that started the panic: reconnaissance. The 1971 Sinai flights had proven it was effectively invulnerable. This was confirmed by the Indian Air Force. From 1981 to 2006, the Indian Air Force operated 10 MiG-25 reconnaissance variants in its No. 102 Trisonic Squadron. For 25 years, these aircraft flew unchallenged over the heavily defended borders of Pakistan and Tibet. During the 1999 Kargil War, an Indian Air Force MiG-25 photographed the entire conflict zone in just 3 sorties, providing critical, life-saving intelligence. The plane's psychological power was proven in May 1997. An Indian Air Force MiG-25 pilot on a routine photo reconnaissance mission over Islamabad deliberately accelerated and broke the sound barrier on his way out. The resulting sonic boom shattered windows and panicked the Pakistani capital, which believed it was under attack. The Pakistan Air Force scrambled its F-16s, but they were helpless. The Foxbat was already back in Indian airspace, its mission a blunt and unassailable show of dominance. Before we continue, I want to hear from you. What aircraft do you think deserves the title of most legendary? Is it the Foxbat with its psychological warfare, the Blackbird with its untouchable speed, or perhaps something entirely different? Drop your answer in the comments below. And if you're enjoying these deep dives into aviation history and want to see more stories like this, make sure to subscribe to the channel and hit that notification bell so you don't miss the next one. Now, back to our story. The MiG-25 also had a bizarre and unique offensive capability as the MiG-25RB supersonic bomber. This variant could carry up to 5,000 kilograms or 11,000 pounds of bombs. The tactic was simple. Fly at Mach 2.35 at 65,000 feet, navigate via the NavAttack system to preloaded coordinates, and drop special heat-resistant bombs. The bombs would fly a ballistic trajectory for dozens of miles. It was a dumb bomb used like a smart weapon, and while inaccurate, it was an uninterceptable way to deliver a massive payload to a large area, like a NATO airbase. Finally, as an interceptor, its record proved the doctrine worked. During the Iran-Iraq War, Iraqi pilots used their MiG-25's to great effect, with Colonel Mohammad Rayyan alone claiming 8 of his 10 kills in the Foxbat, shooting down various American-made fighters and even a transport aircraft. Its most significant kill, however, came on the first night of the Gulf War, January 17, 1991. An Iraqi MiG-25, flown by Lieutenant Zuhair Dawood, was vectored by ground control onto a U.S. Navy strike package. Dawood did exactly what the Air Defense Manual said to do. He acquired a target, fired a single missile, and destroyed the Hornet, piloted by Lieutenant Commander Scott Spiker. It was the first USC's Navy air-to-air loss of the war. The junk plane, used as intended, had drawn first blood. The MiG-25 was a one-trick pony, but it was a hell of a trick. The Foxbat story is defined by its 2 key rivals: the plane it was built to kill and the plane that was built to kill it. The first, the Lockheed Blackbird, was the Foxbat's ultimate target. It was the holy grail of the Soviet Air Defense Force. Soviet interceptors were constantly vectored onto the Blackbird's Baltic Express route. The result was total failure. A MiG-25 never fired a missile at a Blackbird. Blackbird pilots simply did not consider them a serious threat. The reason was simple. The Blackbird cruised at Mach 3.2 at over 80,000 feet. The MiG-25 could sustain only Mach 2.83 at a lower altitude. More importantly, the Blackbird could sustain its speed for hours, while the MiG-25's engines would melt after minutes. As Belenko explained, the Blackbird was simply too high, too fast, and the head-on closure rate of over Mach 5 was too great for the Foxfire's guidance system to ever solve the firing problem. Its second rival, the McDonnell Douglas F-15 Eagle, is the source of the Foxbat's greatest and most ironic danger. The F-15 was born directly from the Foxbat panic. The U.S. Air Force, believing the MiG-25 was a high-speed, agile superfighter, set the performance bar for their fighter program to defeat this phantom. The F-15 was designed to be exactly what the MiG-25 isn't, but what U.S. intelligence believed it was. The comparison is stark. The MiG-25 had a thrust-to-weight ratio of a dismal 0.41. The F-15 had a 1.03, allowing it to accelerate straight up. The MiG-25 was blind below. The F-15 had a revolutionary look-down, shoot-down radar. The F-15 was superior in every single metric except raw, straight-line top speed. The U.S. had freaked itself out into building the single most dominant air superiority fighter of the 20th century, with its 104-to-0 kill ratio to defeat a plane that was never designed to fight it. The MiG-25's greatest legacy was not what it did, but what it made the West do. The MiG-25 itself was an evolutionary dead end. Its steel airframe, thirsty drone engines, and blind radar were fundamental flaws. The true modernization was the aircraft Belenko had warned of, the Super Foxbat. This became the Mikoyan MiG-31 Foxhound, the aircraft the West thought the MiG-25 was. The MiG-31 looks similar, but it is a radically improved machine that fixes every single flaw of its predecessor. The Foxfire's vacuum tube, lookup radar, was replaced by the Zaslon, the world's first phased array radar on a fighter. The Zaslon had a true look-down, shoot-down capability, finally allowing it to track and kill the low-flying cruise missiles the MiG-25 was blind to. The single-seat, high-workload cockpit was replaced with a two-seat configuration, adding a dedicated weapon systems officer to manage the complex radar and missiles. The airframe was strengthened for supersonic flight at low altitude, and new, more efficient engines gave it the range the MiG-25 always lacked. The MiG-25 was dangerous because it was a mystery, a steel and alcohol phantom that goaded the West into a new generation of technology. Its true danger was psychological, but its legacy is the MiG-31, the Super Foxbat that finally became the truly dangerous, high-speed, cruise missile-killing interceptor that the West had feared all along. The Foxbat had to walk so the Foxhound could run. Yet the story doesn't end with the MiG-31's triumph. The Foxbat continued to serve in roles that highlighted both its unique capabilities and its fundamental limitations. Throughout the 1980s and 90s, the aircraft remained a fixture in Soviet and later Russian air defense networks, a testament to the brutal effectiveness of its original design. The reconnaissance variants proved particularly enduring, their combination of speed and altitude creating a niche that few other aircraft could fill. Even as satellite technology advanced and unmanned systems proliferated, there remained situations where a pilot in a cockpit racing through the stratosphere at Mach 2.8 could gather intelligence that no other platform could provide. The psychological impact of the Foxbat extended far beyond its actual capabilities. For nations acquiring the aircraft, it became a symbol of prestige and technological prowess. Libya, Algeria, Syria, and Iraq all operated various versions of the MiG-25, and each used the aircraft as much for its deterrent value as for its actual military utility. The mere presence of Foxbats in a national inventory forced potential adversaries to recalculate their strategies, to consider the possibility that their reconnaissance flights might be intercepted, their high-altitude bombers engaged. This psychological warfare was perhaps the aircraft's most effective weapon, more potent than any missile it could carry. The training required to fly the MiG-25 was as unique as the aircraft itself. Soviet pilots selected for Foxbat duty underwent specialized instruction that emphasized strict adherence to procedures and absolute trust in ground controllers. The aircraft's limitations meant that pilot initiative, so prized in Western fighter training, was not just discouraged, but actively dangerous. A Foxbat pilot who tried to dogfight, who attempted to push the aircraft beyond its narrow performance envelope, was a dead pilot. The training reflected this reality, creating a cadre of aviators who understood that their role was not to be aerial knights, but rather precision instruments in a larger air defense system. This philosophy clashed dramatically with Western concepts of fighter pilot autonomy, creating yet another layer of misunderstanding between the two Cold War blocs. The maintenance challenges of the MiG-25 revealed much about Soviet military logistics and priorities. The aircraft's steel construction, while simplifying certain aspects of repair, created others. The massive weight of the airframe required specialized ground equipment, and the thirsty engines demanded enormous quantities of fuel for even short flights. The alcohol cooling system, beyond its obvious morale implications, represented a constant logistical burden. Bases operating the Foxbat required dedicated alcohol storage and handling facilities, creating vulnerabilities that NATO planners noted with interest. A strike against a Foxbat base's alcohol supplies could ground the entire unit as effectively as destroying the aircraft themselves. This dependency on a single critical resource was a weakness that the aircraft's designers had accepted as necessary, but it remained a vulnerability throughout the type's service life. The international incidents involving the MiG-25 provide a window into Cold War tensions and the aircraft's role as a political instrument. Beyond Belenko's defection, there were numerous occasions when Foxbats probing NATO airspace or flying reconnaissance missions over sensitive areas created diplomatic crises. Each incident reinforced the aircraft's reputation as a symbol of Soviet power projection, even when the missions themselves accomplished little of military value. The sonic boom over Islamabad in 1997 was merely the most theatrical example of a pattern that repeated throughout the aircraft's operational history. These flights were as much about demonstrating capability and resolve as they were about gathering intelligence. The message was clear: we can go where we want, when we want, and you cannot stop us. The environmental impact of operating the MiG-25 was considerable, though rarely discussed in contemporary accounts. The R-15 engines were not just fuel-hungry, they were also prodigious polluters, spewing partially burned kerosene and carbon particles across the stratosphere during each high-speed dash. The noise footprint of the aircraft was similarly dramatic. Afterburner takeoffs would shake buildings miles from the airfield, and the sonic booms generated during supersonic flight caused property damage and public complaints wherever the aircraft operated. These externalities were considered acceptable costs during the Cold War, but they represented another dimension of the aircraft's brute force philosophy. Subtlety and environmental consideration were luxuries the Foxbat's designers could not afford. As the Cold War ended and the Soviet Union collapsed, the MiG-25 fleet faced an uncertain future. Many aircraft were placed in storage or scrapped as Russia's military budget evaporated. The remaining operators, particularly those in the Middle East and North Africa, found themselves with aging fleets and dwindling support from Russian manufacturers. Yet, even in decline, the Foxbat remained relevant in specific scenarios. The reconnaissance variants continued to provide capabilities that newer aircraft could not match, at least not at comparable cost. For nations facing well-equipped adversaries but operating under severe budget constraints, the MiG-25 offered a way to maintain at least the appearance of high-end capabilities. This Indian Air Force recognized this, keeping their Trisonic squadron operational until 2006, long after most observers expected the type to be retired. The final chapter of the Foxbat story is still being written. As of the early 21st century, small numbers of MiG-25s remained in service with a handful of operators, mostly in reconnaissance or training roles. The aircraft had transitioned from frontline interceptor to historical curiosity, a relic of a different era of warfare and geopolitics. Museums around the world display examples of the type, and the Hakodate Airport in Japan maintains Belenko's aircraft as a permanent exhibit, a reminder of one of the Cold War's most dramatic moments. For aviation historians and enthusiasts, the MiG-25 represents a fascinating case study in how perception shapes reality, how intelligence failures can drive technological development, and how an aircraft designed for one purpose can find success in entirely different roles. The Foxbat was never the superfighter the West feared, but it was something perhaps more interesting. A perfect embodiment of Soviet design philosophy, a machine that accomplished its mission not through elegance or sophistication, but through sheer, uncompromising commitment.